Welcome to Bedtime Astronomy. Explore the wonders of the cosmos with our soothing Bedtime Astronomy podcast. Each episode offers a gentle journey through the stars, planets, and beyond, perfect for unwinding after a long day. Let's travel through the mysteries of the universe as you drift off into a peaceful slumber under the night sky. A glimmering abyss, unveiling the nature of the space vacuum. We crane our necks skyward, mesmerized by the celestial spectacle. Countless stars, galaxies, and nebulae sprawl across the inky canvas, their brilliance seemingly suspended in nothingness. But what truly fills the seemingly empty chasm between these celestial wonders? The answer lies in a realm both alien and strangely familiar: the space vacuum. Far from being a void devoid of everything, it's a surprisingly complex environment with unique properties that shape our understanding of the cosmos. Unlike Earth's atmosphere, a swirling ocean of air that presses down on us with constant force, space is a near-perfect vacuum. Here, the concept of empty takes on a whole new meaning. Imagine a thimble filled with air on Earth containing trillions of molecules. In the space vacuum, that same thimble might hold a mere handful, an astonishing contrast that highlights the near-complete absence of gas molecules in this vast expanse. This extreme sparsity translates to a crucial property: the absence of pressure. Unlike the familiar sensation of air pressing against our skin, space exerts almost no pressure at all. This might seem like a benign detail, but for any object venturing out unprotected, the consequences are swift and dramatic. The human body, accustomed to the constant pressure of Earth's atmosphere, would experience the rapid boiling of bodily fluids in a vacuum. Blood would froth, and tissues would swell, a stark reminder of the importance of pressurized suits for any astronaut venturing beyond the protective embrace of our planet. The stifled song, the absence of sound, and the language of radiation. Sound, the very essence of communication on Earth, relies on a medium to travel. Sound waves ripple through air molecules, carrying information to our ears. But in the space vacuum, with its near absence of gas molecules, sound simply cannot propagate. This renders space a realm of profound silence, a stark contrast to the cacophony of everyday life. Here, there's no rustling of leaves, no crash of waves, no chirping of birds. The only occasional disturbances are the bursts of energetic radiation or the distant hum of a spacecraft engine, a stark reminder of the technological marvels that allow us to pierce this veil of celestial silence. However, the absence of sound doesn't equate to an absence of communication. Space, in its own way, has a language, the language of radiation. This encompasses a vast spectrum of energy waves, from the life-giving warmth of sunlight to the invisible tendrils of radio waves that carry messages across the cosmos. High-energy cosmic rays, remnants of distant stellar explosions, streak through the void. X-rays, with their penetrating power, pierce through interstellar dust clouds, revealing hidden celestial wonders. This constant bombardment of radiation necessitates a crucial element in space exploration: shielding. Spacecraft are meticulously designed with layers of protection to safeguard astronauts from the harmful effects of these energetic particles, allowing them to explore the cosmos without succumbing to the invisible dangers that lurk within the space vacuum. A paradoxical embrace, the dance of temperature in the absence of air. One might assume, based on the lack of a heat-trapping atmosphere, that space is a uniformly frigid wasteland. However, the concept of temperature in space is far more nuanced and intriguing. Imagine a spacecraft basking in the direct, unfiltered light of the sun. With no air molecules to carry away heat, the surface temperature of the spacecraft can soar to scorching levels, exceeding 100 degrees Celsius. This highlights a key concept. In direct sunlight, objects in space can become incredibly hot due to the unimpeded transfer of solar energy. Now, picture the same spacecraft in the shadow of Earth or another celestial body, shielded from the sun's direct rays. Here, the story takes a dramatic turn. In the absence of sunlight and with no air to retain heat, the temperature can plummet to near absolute zero, a bone-chilling minus 273.15 degrees Celsius. This vast temperature range, from scorching highs to unimaginable lows, underscores the unique way in which objects in space experience heat transfer. The space vacuum, devoid of air, creates a dramatic temperature dichotomy, where objects can swing wildly between extremes depending on their exposure to sunlight. The unseen hand, gravity's grip on the celestial stage. Though devoid of air resistance, the space vacuum is not a realm of absolute freedom. Gravity, the invisible hand that shapes the cosmos, reigns supreme within this vast expanse. Its influence extends far beyond the familiar pull we experience on Earth. Here, it dictates the grand dance of celestial objects, from the graceful pirouette of a moon around its planet to the majestic waltz of stars within a galaxy. Imagine a massive star, its core a furnace of nuclear fusion. Gravity acts as the conductor, orchestrating the movement of the star's swirling gas and dust. It also dictates the delicate balance between the outward pressure generated by the star's nuclear reactions and the inward pull of gravity. This intricate cosmic ballet determines the star's lifespan and ultimately, its spectacular demise in a supernova or a quiet collapse into a black hole. Gravity's influence extends far beyond individual stars. It binds entire galaxies together, their countless stars, gas, and dust locked in a grand, swirling motion. The intricate dance of galaxies, shaped by gravity's pull, influences the birth and death of stars within them, ultimately shaping the overall structure and evolution of the universe. By studying the gravitational interactions within the space vacuum, astronomers can piece together the history of the cosmos, trace the movement of celestial objects, and even predict future collisions between galaxies. Understanding this unseen force is central to unraveling the grand narrative of the universe. A realm of dust and microscopic meteors, the unseen hazards of the cosmic canvas. The vast expanse of space might appear empty at first glance, but a closer look reveals a surprising presence, a sparse distribution of dust and micrometeoroids. These tiny particles, remnants of comets and asteroids, paint a delicate, unseen portrait across the cosmic canvas. Imagine a cloud of dust, so tenuous that it would take trillions of these particles to fill a thimble on Earth. Yet, within the vastness of space, these seemingly insignificant specks pose a significant threat to spacecraft. Micrometeoroids, tiny pebbles of rock and ice traveling at breakneck speeds, can pierce through spacecraft with devastating consequences. Their impact can damage sensitive instruments or even puncture a spacecraft's hull, potentially jeopardizing the entire mission. To safeguard against these unseen hazards, spacecraft are meticulously designed with layers of shielding, engineered to absorb or deflect the impact of these cosmic bullets. Dust particles, though seemingly harmless due to their minuscule size, can also pose a threat. Over time, they can accumulate on the delicate surfaces of spacecraft, hindering their ability to function properly. This presence of dust and micrometeoroids within the space vacuum highlights the need for meticulous planning and robust engineering in space exploration. Understanding the distribution and properties of these particles allows scientists to design spacecraft that can navigate the cosmic minefield and ensure the success of missions venturing into the vast unknown. A cradle of creation, seeds of stars and planets in the cosmic void. The space vacuum, far from being a sterile and empty void, is a dynamic environment where the seeds of stars and planets are sown. Imagine giant clouds of gas and dust, swirling in the darkness, their forms sculpted by the unseen hand of gravity. These celestial cradles, known as nebulae, are the birthplaces of stars and planetary systems. Within the dense heart of a nebula, gravity begins to exert its influence. As the gas and dust particles clump together, they heat up and ignite nuclear fusion at their core, giving birth to a new star. The leftover material from this stellar birth, swirling gas and dust, can then condense further into planets, moons, and asteroids. This intricate dance of birth and creation, orchestrated within the vast expanse of the space vacuum, underscores its vital role in the ongoing story of the universe. By studying the composition and dynamics of nebulae, astronomers can gain valuable insights into the process of star and planet formation. Understanding how these celestial objects evolve within the space vacuum allows us to piece together our own cosmic origins, tracing the lineage of the Sun and the solar system back to the swirling chaos of a nascent nebula. The space vacuum, once thought of as an empty void, now emerges as a dynamic stage where the grand drama of stellar and planetary creation unfolds. The invisible scaffolding, dark matter and dark energy's mysterious grip. Despite the advancements in our understanding of the space vacuum, a significant portion of its essence remains shrouded in mystery. This enigmatic realm harbors unseen forces, dark matter and dark energy, that contribute substantially to the universe's structure and expansion. Imagine a vast cosmic stage where only a fraction of the actors are visible. Dark matter, invisible to our current instruments, is thought to comprise roughly 85% of the universe's matter. Its presence is inferred through its gravitational influence on visible objects like stars and galaxies. The intricate dance of galaxies, their unexpected movements and rotations, can only be explained by the presence of this invisible scaffolding. Dark matter acts as the missing piece in the cosmic puzzle, providing the necessary gravitational pull to hold galaxies together and influence their large-scale motion. Unveiling the nature of dark matter remains an ongoing scientific quest, pushing the boundaries of our knowledge and requiring innovative tools and techniques to pierce the veil of the invisible. A stage for discovery, unveiling the secrets of the space vacuum. The space vacuum, once viewed as an insurmountable barrier, has become a stage for exploration and discovery. Human ingenuity has led to the development of sophisticated spacecraft and telescopes, allowing us to peer deeper into the cosmos and unravel its secrets. Imagine a robotic emissary, venturing into the vast expanse, its instruments collecting data on the composition, temperature, and radiation within the space vacuum. These robotic explorers, braving the harsh environment, have revolutionized our understanding of this celestial realm. Data from probes orbiting planets, landers on celestial bodies, and telescopes peering into the depths of space have unveiled the existence of hidden planetary systems, exotic stellar phenomena, and the dynamic processes at play within the space vacuum. As we continue to refine our technology and push the boundaries of exploration, the secrets of the space vacuum will slowly surrender, revealing a universe far more complex and fascinating than we ever imagined. A challenge and an opportunity, exploring the unforgiving frontier. The space vacuum, for all its beauty and intrigue, presents a daunting challenge for human exploration. The harsh environment, characterized by the absence of pressure, extreme temperatures, and radiation bombardment, necessitates meticulous planning and robust technology. Imagine an astronaut venturing outside a spacecraft, protected by a pressurized suit, a technological marvel that safeguards them from the unforgiving embrace of space. Despite the inherent dangers, the space vacuum also represents an opportunity for scientific advancement and human ingenuity. By developing advanced life support systems, radiation shielding, and robust spacecraft materials, we can overcome the challenges of space travel. Each successful mission, Each daring exploration expands our knowledge and paves the way for future endeavors. The human spirit of exploration, fueled by insatiable curiosity, compels us to venture into the unknown, to push the boundaries of space travel, and ultimately, unlock the secrets of the space vacuum. The space vacuum, once a symbol of emptiness, has emerged as a dynamic and intricately woven celestial canvas. Far from being a void, it's a realm teeming with unseen forces, hidden particles, and the seeds of stellar creation. Understanding its properties, the absence of pressure, the dance of temperature extremes, and the influence of gravity, allows us to appreciate the delicate balance that shapes the cosmos. As we continue to explore this celestial canvas, the space vacuum holds the promise of further discoveries, unveiling the mysteries of dark matter and dark energy, unlocking the secrets of star and planet formation, and potentially finding new homes amongst the stars are all within the grasp of our expanding knowledge.